I'm Chris Carlson, a graphics developer with Wolfram Research. In the next half hour, I'll show you how you really can build an app in 60 seconds from any concept that you can express in Mathematica. I'll tell you all about Manipulate, Mathematica's star function for interface building, and describe the full range of controls available to you and how you can use them to quickly build effective apps. I'll tell you how to make your apps beautiful, enhance their usability, and polish their interfaces. And I'll give you examples of using Manipulate to explore any concept, whether it's text, graphics, sound, or something else. So here's the 60-second app. To keep myself honest, I'll start a 60-second timer. This expression shows a phenomenon of beat frequencies. To turn it into an interactive app, I'll replace the fixed frequency by a frequency f and add a phase theta. And I'll give myself some options for filling. I'll wrap the whole thing in Manipulate. I'll let f go from 10 to 20 and theta from 0 to 4 pi. Let the fill be either none or axis with an initial color of pink. And that's it. With time to spare, I've completed an interactive app and I can explore the phenomenon of beat frequencies interactively. Manipulate is the main function to use in Mathematica to build interactive interfaces, from quick one-off explorations like the 60-second app I just showed, to sophisticated full-featured applications. Manipulate gives you a wide range of controls and functionality to work with, but configures much of it for you automatically so you don't get bogged down in the details of the interface. If you want more control over appearance and functionality, you can override Manipulate's defaults. I'll show you how this all works by looking now at how you might build an app for exploring polyhedra. Mathematica knows a lot about polyhedra, and what it knows is encapsulated in the function Polyhedron Data. Evaluating polyhedron data without any arguments gives you a long list of the names of polyhedra Mathematica knows something about. If you supply one of those names as the first argument to polyhedron data, you get an image of that polyhedron. Since polyhedron data without arguments returns the list of polyhedron names, you can index into the list to pick out particular polyhedra. This expression, for example, gives an image of the first of the polyhedra that polyhedron data knows about. To make a list of the first 10 polyhedron in polyhedron data, use table and let the index I run from 1 to 10 in steps of 1. Manipulate is similar to table. In fact, in this case, all you have to do to turn this table into an interactive interface is replace table with Manipulate. Manipulate gives you an interactive slider that controls the polyhedron index. Maybe you'd like a drop-down menu of polyhedron names instead of a slider. Just let the name range over the names in the list returned by polyhedron data. Mathematica automatically determines that a drop-down menu is more appropriate than a slider. With a drop-down menu, you can choose polyhedra by name directly. You can have both a slider and a drop-down menu if you want. Both can be useful depending on whether you want to choose specific polyhedra or quickly browse through all the possibilities. To add a slider, just duplicate the name control and specify that the second instance of the control should be a slider. Now you have two coupled controls, and the slider gives you quick access to the entire list of polyhedra for easy browsing. The drop-down menu conveniently shows you the name of the polyhedron that's displayed. If you want to see a particular polyhedron, you can choose it from the drop-down menu. Suppose you'd like to browse stellated polyhedra. A stellated polyhedron is derived from a polyhedron by gluing pyramids to each of its planar faces, creating a new star-like polyhedron. Mathematica provides the stellate function to do stellations. It's located in the polyhedron operations package, which you can load by evaluating needs. To apply stellate to a polyhedron, give the polyhedron as the first argument and the stellation ratio, which controls the heights of the pyramids, as the second argument. To add stellation to the Polyhedron Explorer interface, you just wrap the polyhedron with stellate and give a stellation parameter of r, and let r range from 0 to 2 with an initial value of 1. You can quickly explore the range of stellation effects by dragging the slider. When you're exploring stellations, it's convenient to be able to return to particular exact values of the stellation ratio when you've moved the slider. You can add that functionality by adding another control for R and specifying a list of preset values for the stellation ratio. Now you can drag the slider to explore stellations and then quickly reset the stellation parameter to an exact value of 1, which gives no stellation at all. You can control just about anything in a manipulate, including function names. If you're interested in truncation as well as stellation, you can add a control that chooses the function that's applied to the polyhedron. Replace stellate with a parameter f, and let f range over stellate, truncate, and open truncate. Here's stellation. Here's truncation. And here's open truncation, which leaves holes where the polyhedron is truncated. Mathematica offers a rich set of controls for building manipulate interfaces. Let's take a look at what they are and how you can customize them to suit your application. As you've seen, Manipulate automatically chooses a control type appropriate to the kinds of values its variable can assume. If you specify a range of values, Manipulate gives you a manipulator, which is a slider with extras. The extras are exposed by clicking on the button to the right of the manipulator, animation controls that you can use to set the slider in motion with an invisible finger, and an input field that you can use to set the slider to an exact value. If you'd rather have a slider without the extras, you can specify slider explicitly. To orient a slider vertically, specify a vertical slider. Vertical slider makes more sense when it's placed to the left or right side of the manipulate, which you can specify using the control placement option with the position of left. An animator is a slider plus animation controls. You can make the animation go faster or slower, make it go forward or backward, or you can pause the animation and single step it. By default, animators are in motion when you evaluate them, but you can set them to be initially off by setting Animator's animation running option to false. You can customize the behavior of any control by specifying control options. A trigger is like an animator, but it runs only once when its play button is clicked. The animation rate option specifies how quickly the animation should run in units per second. Triggers are useful for one-shot sequences of motion. If you specify a range and include an increment, you get a manipulator that takes on discrete values. In this case, it's even numbers. If the range of a variable's values consists of pairs of numbers rather than single values, Manipulate chooses a 2D slider. I'll let this one range from 0, 0 to 4, 4 with an initial value of 2, 2. This 2D slider controls the position of the triangle's vertex. 2D sliders can be discrete valued, just like 1D sliders. Just specify an increment in addition to the range. Now my triangle's vertex is constrained to integer grid points. For small lists of values, Manipulate chooses a SetterBar control. Here I'm using the SetterBar to choose which function is plotted. For larger lists of values, Manipulate automatically chooses a pop-up menu instead. But if you would really rather have a SetterBar, you can override Manipulate's default choice by specifying the control type explicitly. An alternative control for lists of values is the RadioButton Bar. A RadioButton Bar is functionally identical to a SetterBar, but it has the appearance of the one-at-a-time buttons on an old radio. As you saw in the first 60-second app, a slider can select values from a list. But the things in the list can be anything at all. They don't have to be numbers. They can be text, graphics, images, or anything else you can express in Mathematica. When a list consists of only true or false, or 0 and 1, Manipulate gives you a checkbox. Here I use a checkbox to control whether or not my plot is filled. You might have noticed that since the fill variable is Boolean valued, but the values of the filling option are axis and none, I had to use an if function to select between the two based on the value of fill. There's a more direct way to handle this case. You can let the fill variable take on the values none and axis. By default, since the values are not Boolean values, Manipulate assumes you want a SetterBar. But as you've seen before, you can specify explicitly you'd rather have a checkbox. If a variable's value is a color, Manipulate gives you a color slider. You can choose a color by mousing around in the palette area. I find this control to be a little small. To get a larger control, you can specify its image size explicitly. This control is easier to use. An alternative control for setting colors is the color setter. Clicking a color setter brings up the system color dialog, which gives you a richer set of color choices than a color slider. If you specify a variable in a Manipulate without any other information, Manipulate gives you an input field. Here I've given myself an input field so I can type in arbitrary functions to plot. There's one control that doesn't reside in the Manipulate panel like the other controls. It's called a locator, and it's useful for implementing direct manipulation interfaces. It works like this. If you specify a coordinate-valued control, you get a 2D slider by default. But it's more natural to drag the corner directly. You can do that by specifying a control type of locator. When the content of a Manipulate is a graphics object, the value of a locator is its coordinate position in the graphic. Now I can drag the corner directly. Locators are useful in all sorts of graphical applications. Here I've used one to control the amplitude and wavelength of a sinusoid in a plot. The value of a locator can be a list of points as well as a single point, which gives you multiple locators in a graphic. This Manipulate shows me the relationship between a spline and its control points. By specifying locator auto-create true, you can create new locator points in the interface by command-clicking on Mac or alt-clicking on Windows. Delete locator points by command-clicking or alt-clicking the points. You can find a complete list of controls by pressing F1 to open the Help browser and typing guide/control objects. For an in-depth tutorial on using controls, visit tutorial/introduction to control objects. I've shown you how to make your Manipulates functional. There are a number of ways to make them beautiful too, as well as enhance their usability by changing the labels, layout, and annotations of controls. Here's how to improve the appearance and usability of an image processing application. This Manipulate shows the effect of adjusting an image's contrast, brightness, and gamma correction, as well as the result of applying image effects like charcoal rendering and motion blur. It's perfectly functional, but its bare-bones interface could be made more understandable and more inviting to use. To begin with, I'll move the controls to the left of the Manipulate contents to give myself more room to work without making an inordinately tall interface. By default, Manipulate labels each control with the name of the variable that it controls. But you can override that default with a more explanatory label by specifying its value after the initial value of the variable. I'll give each control a more meaningful label. Now it's easy to see what the effect of each control is. I don't care about the extras that the manipulator control provides to the right of the slider, but I would like to see the slider values displayed next to them. I'll change each manipulator to a slider and make it display its value to the right by specifying appearance arrow labeled. Now I can see what's happening numerically as I drag the sliders. The 6 controls in this manipulate belong to 2 groups, one for adjusting the image appearance and one for controlling the image effect. But that structure isn't apparent in the interface. You can make the structure clear by separating and labeling the groups of controls. You can add any annotation you want among the control specifications, which I'll use to group the controls, and while I'm at it, I'll add a title for the whole manipulate. That makes the control groups clear, but the formatting could be improved by some judicious use of vertical whitespace and lines that delimit the control groups. I'll add some whitespace by inserting blank lines into the controls and delimiting lines using the keyword delimiter. Now the interface clearly communicates that you can explore 2 kinds of functionality with it, image adjust and image effect. That's looking pretty good. I'll polish it off with one final tweak. The interface could use just a little more white space all the way around. The controls are uncomfortably tight to the edges of the panel. You can't adjust the margins of the Manipulate panel directly in Manipulate, but you can remove the default panel that Manipulate provides and add your own custom panel. Panel arrow false removes the panel. You can add any background or frame to this bare bones Manipulate that you like. I'll replace the panel with a frame and give it a margin of 30 pixels so that the panel edges are not so tight to the contents. That gives me an interface with a clean, minimalist look. An alternative possibility is to isolate the image on a black background. You can use Frame's background option to specify black and its base style option to set the default font color to a light gray so that it shows up on the black background, but with a muted contrast that doesn't distract from the image. I've shown you how to manipulate images, 3D graphics, and plots, but you can manipulate anything at all that you can express in Mathematica. Here are some examples. This Manipulate shows the relative frequencies of characters in a text by highlighting the character chosen by the slider. You can manipulate symbolic math, as in this app that shows a symbolic result of an integration for integer values of the exponent on x. You can manipulate sound to explore polyrhythms, for example, such as 2 beats against 3 or 3 against 5. You can even manipulate running programs as they run and change program settings and parameters. With Manipulate, you can build everything from quick one-off explorations to sophisticated production quality interfaces, like this model of the technical aspects of common color spaces. Our time is up, but there are thousands of examples of how to use Manipulate to explore topics in a huge variety of areas online in the Wolfram Demonstrations project at demonstrations.wolfram.com. You can download the source code of any demonstration and experiment with it to learn new Manipulate techniques from other people's examples. It's a good way to get up to speed with Manipulate and have fun exploring interesting topics while you're at it.